Hello guys, welcome to today's lesson. Today we're going to be talking about what the fundamental theorem of algebra is and what complex solutions are in polynomial functions. Again, we're talking about polynomial functions, alright? So let's go ahead and get started. The fundamental theorem of algebra states that any polynomial of degree n has n number of roots. All right. So the fundamental theorem of algebra states that any polynomial of degree n has n number of roots, and when we talk about the number of roots, we are including real roots and we're including complex roots, okay? And we're going to talk about that in just a minute, what I mean by complex roots. So the fundamental theorem of algebra tells us that degree n has n number of roots, real and complex. So let's look at example number 1. In example number 1, we need to determine the degree. The degree of this function is the highest exponent. So the degree is x to the third. So the degree is 3. So how many roots is it going to have? This function will have 3 roots. All right. Let's do example number 2. The degree on number 2 is the highest exponent. One more time. The highest exponent is 5. So this one will have 5 roots. Okay. And that's pretty much what the theorem says. It's not very complex. It's just kind of straightforward to the point. So go ahead and try example number 3. Pause the video. All right, so hopefully you paused the video and tried it. The degree on number 3 is 9, so this function will have 9 roots. All right, any questions? Hopefully not. So let's go ahead and talk about complex roots. What are complex roots? A complex root is a root in the function that is a complex number. All right. So a complex root is a root in the function that has a complex number. And what do we mean by complex number? A complex number is an imaginary number. And I'm not sure if we've worked with imaginary numbers, but imaginary numbers typically have some number plus b times I. And this part right here, the I, is what makes it imaginary. This is the imaginary part, the imaginary number. Okay? So complex roots are roots in the functions that are a complex number. Complex meaning they are imaginary. One thing that you need to know is that you cannot see a complex root on the graph because it's imaginary. Okay, so you can't see it, so you won't see it. And then another thing to know is that complex numbers, complex roots come in pairs, all right, with one being positive and one being negative. All right, so that's what we're talking about here with complex roots. Complex is a root in the function that has a complex number or imaginary. So you have a plus bi, or you have a minus bi, because they come in pairs. And it's really not that complicated. We don't really have to work too much with complex numbers in this class. Just know that they come in pairs, one positive and one negative. All right, so let's go ahead and look at these graphs. For example, so here let's determine how many real and how many complex zeros does each of the following functions have. So let's look at this one. If this is a degree 3 How many times does it cross the x-axis? How many times does it cross the x-axis? Well, if you look at this first example, it crosses one time. So therefore we have one real zero, but we know that the degree is 3, so we need to have 3 zeros. We need to have 3 of those because that's what the fundamental theorem of algebra says. That's what we just learned up here. So if it has one real, that means there are 2 complex zeros. All right, so let's go ahead and try this one. How many reals does this one have? So again, let's look at my graph. Where does it cross the x-axis? It crosses the x-axis right there, and it only crosses once, so it has one real zero. And it's a degree 3, so that means it's supposed to have 3 zeros. That implies that we have 2 complex. All right, let's go ahead and try the next one. How many reals does this function have? This function crosses the x-axis 1, 2 times. So that one has 2 real zeros because we can see where it crosses. And if it's a degree 4, we're missing 2 complex. All right, go ahead and try the last one. How many times does this one cross the x-axis? How many times does this graph cross the x-axis? 0 times, so it has 0 real zeros. And if it has a degree of 4, that means it must have 4 complex, like that. All right, and last thing that I wanted to cover for today is, let's look at the thinking task. Is it possible for a function of the 5th degree to have 2 real and 3 imaginary? Let's think about that. Is it possible for a function of the 5th degree to have 2 real and 3 imaginary zeros? Pause the video if you're not done thinking. If you are and you think you got it right, the answer to this question is no, because complex zeros or imaginary come in pairs. All right, so the answer to this one is no, because complex or imaginary zeros come in pairs, meaning that if you have, for example, a positive 4i, you're going to have a negative 4i. Again, this is just an example that I made up. So you're always going to have a positive 1 and you're always going to have a negative 1. So the only number of imaginary zeros you can have is either 2 imaginary or 4 imaginary or 6, and you continue that way because they have to come in pairs. So you can only have 2 imaginary, 4 imaginary, or 6, because you always have a positive and you always have a negative. So this would be an example of something that would look like a complex number. Just to show you another example, because I ran out of room on the top, you could have something like this, 3 plus I, and you would have 3 minus I. But we're not working too much with that. These two can be written like this as well, 3 plus or minus I. So that would be an example of a pair of complex numbers. All right, guys, that's it for today's lesson. Hope it wasn't too complicated for you. Have a good day.